Hey everyone, so this video we are going to talk about writing the name and formula for ionic type 1 compounds. Just a quick refresher from the types of compounds. We know that it's ionic if the first thing we see is a metal. So first element is a metal. Oops. And we know that it's type 1 if we know the charge of that metal. These are going to be the easiest, I think, to write the name and formula for, and that's why we're starting with it, kind of ease you guys into it. But just because it's easy doesn't mean you can't make a mistake. So just keep in mind, as we add more stuff, it's going to get more complicated and it's going to seem like it's impossible, but you just have to kind of take it one thing at a time, remember the separate rules, and remember how easy it was when, we first started. So, okay, writing the name. We already kind of talked about this in one of the videos, but it's basically two super simple rules, two like easy steps. Step 1 is we name the metal. Step 2, name the nonmetal. But we can't just name it. We have to change the ending to IDE. So name the nonmetal, change the ending. Remember, triangle means delta. Delta means change. Change the ending to IDE. So let's do some examples. Let's say I have Al2, or let's just do Al2S. S3. We have BAS. Let's just do these two. Okay, so Al2S3. Again, I name the metal first. Name the metal. And Al is aluminum. ALUMINUM. And then we name the nonmetal, but change the ending to IDE. So I know that this is sulfur, but sulfur is going to become sulfide. So aluminum sulfide. And let's do a different one. Let's do BaO. Oops, it's supposed to be orange. Oh well. So again, name the metal, change the ending to IDE for the nonmetal. So Ba, hopefully you remember, is barium. And O is oxide. Now, some people might struggle with the spelling for those IDE ones, and trust me when I say we're going to do it so much that it's going to become like second nature. But if you do want to write them down, here's the spelling for all the non-metals that we might see. So you can pause the video, write these down, or what have you, so that you have them to reference when and if the time comes. All right, so writing the name, again, super easy. I'm not going to take much time there. Writing the formula now. So in class, we talked about how all compounds need to be neutral, right? So let me figure out what color to get here. So all compounds are neutral. And saying that we have, these positive and negatives come together, obviously they need to cancel each other's charge out. So the example we used in class before was magnesium chloride. So I'm just going to go with that one. And when we do this, obviously we need to write the symbols if we're writing the formula. So magnesium is a Mg, chlorine is a Cl. I know the charges of them because it's a type 1. So magnesium is a +2, chlorine is a -1. And so the process that we kind of went through together in class the other day was if magnesium has a total of +2 charge and I need chlorine to cancel that out to equal 0, well, then I need another chlorine in there to get that -2 charge because 2 and 2 cancel out, right? And so this tells me that I have 2 chlorines and 1 magnesium. So MgCl2. And we don't write the 1, that's just redundant because obviously there's 1, there's, the symbols there. So there has to be at least 1. So we only write it, if there's more than 1, hang on, sorry, this should be a 1. So, we can see the math behind the formula, but there is a much easier way that doesn't involve math, that doesn't involve thinking at all. And I think that everyone would agree that that method is always better. So here are the rules. 3 easy steps. Oh my gosh, what is wrong with me? You guys bearing with me on that end? Yikes. Okay. Step number 1, symbols. Just like before. Step number 2, charges. Just like before. Step number 3, instead of getting all mathy and figuring out this charge and that charge, you just crisscross. Symbols, charges, crisscross. Symbols, charges, crisscross. Symbols, charges, crisscross. Okay, what does that mean? Let's do magnesium chloride again. So symbols, Mg. Chlorine is Cl. Charges, so I did symbols. Here's charges, plus 2 minus 1, crisscross. So here's what I mean by crisscross. We're going to take this quantity, this number, and we're going to cross it down to become chlorine's subscript. And we're going to take this number and cross it down to be magnesium's subscript. And again, we don't write ones, so it's just telling us that there's only one of them. So it becomes MgCl2. And it's done. And hopefully that's easier for you guys than trying to go through all the math. Now, it's not like this charge comes down and becomes chlorine's charge. No. This is the math. This here in green, this is just a trick, a shortcut, and it works every single time. So let's take a look at another one. Let's do aluminum sulfide. And we'll try calcium. Let's do calcium. Let's do calcium oxide. And one more, let's do beryllium bromide. Okay, so aluminum sulfide, symbols, charges, crisscross. The symbols are Al for aluminum, S for sulfur. The charge for aluminum is +3. The charge for sulfur is -2. And I'm getting this from the periodic table. Obviously, I have these memorized because I've been doing this for forever, but you could just look at the periodic table and get the charges. And then finally, we crisscross. The 3 goes with the S, the 2 goes with the aluminum, and my final answer is Al2S3. Good? Let's do the next one. Calcium oxide, C, A, and O. I have a +2 and a -2. Now, be careful here. When we crisscross, it's going to look like I should have Ca2O2. But remember, we can reduce, we can simplify. I don't need 2 calciums and 2 oxygens. I can just have one of each and they'll cancel out. So you always need to check your subscripts to make sure that they're the least common ratio there. So instead of Ca2O2, I'm just going to have CaO. So don't forget to reduce. And then beryllium, actually, I'm going to change this to show you guys another kind of tricky thing. Let's do beryllium carbide. And so when we're writing this, beryllium, Be, carbide is carbon, that's a C. Beryllium, his charge is easy. We know that it's +2. Carbon, on the other hand, if you recall, he is in our group 4A, so he can have a +4 charge or a -4 charge. And to know what he's going to do, remember, it depends on who he's bonding with. So if carbon is bonding with a positive beryllium, then we know that he must be negative. Otherwise, they wouldn't go together, right? So carbon, instead of, we say, oh, I don't know if it's positive or negative, it's going to be -4, again, because they need to cancel each other out. So here, again, we crisscross. The 2 comes down, the 4 comes down, and we have BE4C2, but just like we did up here, we have to simplify, we have to reduce. And so this is going to become BE2C. So there's just a couple, like, I don't know, and it's not tricky, but just things to remember, like simplifying, like knowing, you know, what the charge is going to be. Just like carbon, the same thing is true with hydrogen. Hydrogen can be +1 or -1. You know, he's just a pain in the buns. So here, I'm just going to put this up on the screen in case you want to pause it. This page is just a little bit neater. But there you have some examples and you have something to work with. So that down at the bottom, you can do the practice. And let me know what you guys need. If you need any help or if I missed something, just let me know. Thank you.